In Chapter 5, we saw contingency tables for the first time, and that was because I cut section 4.4 from there and I put it here at the end. And I wanted to revisit contingency tables for a second. Remember, you have a column variable and a row variable. And the reason I put them here is because they're for dealing with qualitative data in two different data sets. And that means that we can run a hypothesis test on them. Well, actually, you can run one of two tests on them, either a test for independence or a test for homogeneity of proportions. So let's take a moment and figure out what the difference between those two types of tests is, and then we'll learn how to run them. So when we summarize categorical variables in a two-way table, like class and ethnicity, things like that, we do that because it helps us see whether there are associations that exist between the variables. When we examine a two-way table, or any data summary for that matter, one aspect that gets hidden is the method that was used to collect the data. That is, the data that appear in a two-way table can be collected one of two ways. So way number one is when you collect just one sample. So for the objects in the sample, we record two categorical response variables. For example, we might collect a large sample of people and record their marital status and education level. If we're going to run a test on that, that would be a test of independence. Let me just scroll down for a second so you can see the hypotheses here. So a test for independence is going to be really simple in the setup for how you set up your null and alternative hypotheses. You're going to say for the null hypothesis that the row and column variable are independent. Now don't say row and column variable, actually say what they are. Like for example, the marital status and education level, there they were. So the marital status, education level, they're independent. The alternative to that is that they are dependent. That would be a test of independence. Very, very simple setup for the hypotheses. Now, a test of homogeneity is a different type of test. So that's when you collect your data in two or more distinct independent samples, one from each population. So each object sample has a categorical value that you record. So for example, collect a random sample of men and a distinct random sample of women. So don't do husbands and wives and things like that. One random group of men, one random group of women. And then we could ask every person in each group whether they think same-sex marriage should be legal in the US. Okay? And then what you'd be doing is you'd be testing the proportions for the groups. Does group 1 think the same way that group 2 does? And it doesn't have to just be two groups. Actually, two groups we've already done in chapter 11. You could do it for different ethnicities. So do Caucasians feel the same way as African Americans, feel the same way as Asian Americans, feel the same way as Hispanic Americans? Do they all feel the same way about same-sex marriage? That would be a test for homogeneity. And what you do is you say the proportion for group 1, say like Caucasians, is equal to the proportion for African Americans, which is equal to the proportion for Asian Americans, and so on. And you'd work your way down the list and say all the proportions are equal to each other. The alternative to that is that at least one of the proportions is different from the others. Okay, so if the word independent is used somewhere in the problem, that's generally a sign that it's going to be a test of independence. Now, that's not 100% sure, but it's very, 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 very frequent. So most often when you see the words independent and dependent thrown around, it's going to be a test of independence. If the problem discusses differences in proportions, what percentage do this, what percentage do that, that's usually a sign of a test of homogeneity. Now, I'm being a little fudgy here, and that's because the tests themselves are actually the same test. There's no difference in how the tests are run, except for the null and alternative hypotheses. That's it. Other than that, they are identical tests. All right, so let's take a moment and try to figure out, are we dealing with one sample, right? For the subjects in the sample, we collect two categorical response variables, or dealing with two or more independent samples, one from each population. Then we collect one thing about them. Okay, so let's go down here. In the 2008 US presidential election was historic for many reasons, but one was that a woman, Hillary Clinton, and an African American, Barack Obama, both had good chances of winning the Democratic nomination. Before the Democratic National Convention, the General Social Survey polled a random sample of 1,286 people eligible to vote and asked whether they would vote A for a woman and B for an African American. One question of interest is whether those who would take the historic leap of voting for a woman for president would also be willing to vote for an African American. So this is a while ago, but what happened was in the Democratic lead up, because they have to pick whoever the Democratic candidate's going to be in the primaries and caucuses and so on. And so what was leading up to that was it was coming down to Hillary Clinton, an African American, which meant or Hillary Clinton and Barack Obama, so a woman and an African American, and that meant that one way or another, the Democratic nominee was going to be a type of nominee that we'd never seen before from one of the major parties, i.e. a woman or an African American, at least not for the role of presidents. All right, so if we want to test whether a person's willingness to vote for a woman for president is associated with their person's willingness to vote for an African American president, would that be a test of homogeneity or a test of independence? All right, so let's go back here and just look again. If you have one sample right here, that you ask two categorical response variables from right here, that would be independence. If you have multiple distinct samples and you ask something of them, like ask one thing of them, like same-sex marriage, that would be homogeneity. So each sample has a categorical value. See that right there? A categorical value. So you're measuring one thing about two or more distinct groups. See that? And this one has one sample, and then you measure more than one categorical thing about them. Okay? So which one are we looking at here? We have one group of 1,286 people, and they're asking them if they're willing to vote for A, a woman, and B, an African American. So that means it's one group asked two questions. That is a test for independence. All right, so now let's write our hypotheses. So the null hypothesis, sorry, I forgot to say this. It's one group of 1,286 eligible voters asked two questions. That is a test of independence. Now I'm going to write up the hypotheses, and I'll be right back. There we go, we have it. So the two options, the variable in this is voting for a woman and voting for an African American are independent. So whether I vote for a woman, whether I'm willing to vote for an African American are completely independent of each other. And then voting for a woman and voting for an African American are dependent. Technically it's not votingness, it's willingness to vote. I should put that in there. There, that says a little bit better. Willingness to vote for a woman, because these are eligible voters, they haven't actually voted. So willingness to vote for a woman and willingness to vote for an African American are independent. Willingness to vote for a woman and willingness to vote for an African American are dependent. All right, the Pew Research Foundation conducts a regular survey to measure consumers' attitudes towards certain products. In 2006, Pew randomly sampled 2,000 people and asked whether they considered a TV set a luxury or necessity. In 2009, while the U.S. was in the middle of that's a typo, that word just had to get deleted, one of the most severe recessions in history, Pew asked another random sample of 1,003 people the same question. The researchers wanted to know whether consumers' attitudes about TV sets have changed since 2006. They plan to carry out a formal hypothesis test to see whether there exists an association between the variables year and attitude. Okay, so will this be a test of homogeneity or independence? That would be homogeneity. And you can tell it's homogeneity because they have two separate years. They're taking this survey in 2006 right here. And then they're doing it again in 2009. So they have two separate groups of which they're asking them questions about. They're asking them a question about whether a TV set is a luxury or a necessity. That's one question they're asking in those 2 years. So if you recall, when you ask one question from 2 different years, 2 different samples, that's homogeneity. I just thought I'd add this little note in here just because I think maybe it'll help clarify. The independence ones are when you have one sample asked basically one question that can have a couple different categorical response variables. And then the homogeneity ones are when you have 2 or more samples asked a question. Now keep in mind that doesn't mean you're going to have only one option. You're going to have variability here. So you're asked about one question that can have several qualitative values. But in general, if it's more than one sample, that's going to be the homogeneity. If it's one sample, that's going to be independence. And this particular one, we have more than one sample. We have 2006 and 2009. So that is a red flag that this is homogeneity, if I could spell it right. There, it's two distinct samples asked whether a TV is a luxury or a necessity. So the two separate groups right there means this is going to be for homogeneity. Now the hypotheses for this particular one are pretty simple and easy because there's only two groups, right? It's 2006, 2009. So the null hypothesis is that the proportion of people that think that a TV is a luxury, for example, are going to be the same in the 2 years. So let me write that up. There I have it. Now this one's pretty basic just because there's only 2 years here again. So it's the proportion for 2006 is equal to proportion in 2009. And keep in mind, I just had to pick one of them. So I let P be the proportion of people that think that TV, I should say of people that think TV is a luxury. And then the alternative is that at least one of these has to be different, which since there's only two, that would mean that they are different from each other. So I realize at this point that this doesn't look too different from chapter 11, and it's not at this point, at this stage in the alternative hypotheses, but they of course can be different when you actually run the test. All right, let's stop right there. We've seen how to tell the difference between a test for homogeneity and a test for independence. So we know that that's how they're going to work, and then we'll come back here and work some more on some two-way tables in the next video and learn also how to find expected values. So we'll do that then.